Once again, happy mind everyone. In the last video, we discussed what is the wave particle duality of matter. Followed by wave particle duality of matter, we discuss what is the de Broglie equation arise for the de Broglie relationship. In this video, we are going to discuss about the quantization of angular momentum with the de Broglie concept. Already we discussed about what about the limitation of Bose atom. In a Bose atom, the main limitation is the Bose theory was unable to explain why the electron is restricted to revolve around the nucleus in a fixed orbit in which angular moment of electron equal to nh divided by 2 pi. And a logical answer for this was provided by a de Broglie equation. Now, based on the de Broglie equation, how will you say the angular momentum will be equal to nh divided by 2 pi? So, this is called as the quantization of angular momentum and de Broglie concept. Now, the de Broglie concept can be explained based on the matter wave. What is the matter wave? The particle can be associated with the wave, that is called as a matter wave. Based on the matter wave, it is given the one equation, that equation called as a de Broglie equation. What is the equation? Lambda equal to h divided by p. A lambda is a de Broglie wavelength, h is a Planck constant. What is the value for that? 6.626 into 10 power minus 34 joule second. The p is nothing but momentum. The momentum which is equal to the product of mass and velocity. So we already told you, if velocity is equal to 0, then the lambda is infinity. It means that waves are associated with the moving particle only. So based on that, here we are trying to explain what about the quantization of angular momentum. That is nothing but the angular momentum which is equal to nh divided by 2 pi. Otherwise, mvr which is equal to nh divided by 2 pi. According to the de Broglie concept, the electron that revolve around the nucleus exhibit both particle and wave character. In order for the electron wave to exist in a space, otherwise the electron wave is out of space. Now we'll see when the electron wave can exist in a space, otherwise when the electron can be exist in a out of space. The space is nothing but around the orbit. Okay, எப்போ எலக்ட்ரான் வந்து பார்த்தா ஆர்பிட் ரிவால்வ் ஆகும், அதர்வைஸ் எப்போ எலக்ட்ரான் வந்து பார்த்தா ஆர்பிட் வெளியே எனக்கு போகும். அதை பற்றி எக்ஸ்பிளைன் பண்ணுறது என்ன சொல்றாங்க? That de Broglie concept. So this is called the quantization of angular momentum. If the electron it has a definite angular momentum, it can exist in a phase. Otherwise, if the electron does not have any definite angular momentum, it cannot exist in space. Otherwise, you can say the electron wave is out of space. If the electron can be exist in the phase, is allowed. Suppose if the electrons cannot be exist in space or in outer space, is not allowed. ஒரு எலக்ட்ரான் ஒரு ஆர்பிட்டால எனக்கு ரிவால்வ் ஆனாக்கா the electron must be possess a definite angular momentum. Otherwise, it cannot exist like that. So, இங்க not allowed நாக்க ஒன்றும் இல்லை, அந்த மாதிரி ஒரு electrons ஒரு atom இருக்காது. அப்படி இருந்தாக்கா what about the electrons can be collided with the nucleus. So, the structure of atom will be collapse. So, from that we are assuming one thing, if the electron can be revolve in a fixed stationary path, it has to possess a fixed angular momentum. Then only it can exist in a phase, otherwise it cannot be exist in a phase, or it will be out of its phase. Now we will see the derivation for the angular momentum of the electron equal to nh divided by 2 pi, or the mvr which is equal to nh divided by 2 pi. So this is the main applications of de Broglie relation. Now see what the derivation. How will you derive that? The circumference of the orbit should be an integral multiples of wavelength. And the circumference எதுக்கு ஈக்குவலா இருக்கும்? The integral multiples of wavelength. So 2 pi r which is equal to n lambda. Here r is the radius of the orbit, n is the whole number. This is a principal quantum number like 1, 2, 3, 4, etc. The lambda is de Broglie wavelength. We know that based on the de Broglie, lambda which is equal to h divided by me. When I substitute equation 2 in 1, we will get 2 pi r which is equal to nh divided by mv. So if I rearrange that, we will get mvr which is equal to nh divided by 2 pi. The equation 3 is indicate the quantization of orbit. So in the equation 3, mvr which is equal to nh divided by 2 pi. Based on the equation 3, so the every orbit does the quantized, or the energy of the electron will be quantized. So definite or electron or particular or definite angular momentum இருந்தா மட்டுமே அது வந்து ஒரு particular stationary path revolve ஆகும். Otherwise the electron will be collided with the nucleus. The atoms are unstable. So these are the main applications of de Broglie relationship. So the main postulates of Bohr's atomic theory, it will be corrected by a de Broglie relationship. So is the de Broglie relationship is given the logical answer for the electron restricted to revolve around the nucleus in a fixed orbit in which angular momentum of electron equal to nh to be 2 pi mer, which is equal to 2 pi. From the above equation you can say the angular momentum will be quantized, or the orbital is a quantized, the energy of the electron will be quantized. The above equation MVR, which is equal to nh by 2 pi, already predicted by a Bohr. Hence the de Broglie and Bohr's concepts are in argument to each other. ரெண்டுமே ஒன்னத எக்ஸ்பிளைன் பண்ணாங்க. பட் போர் என்ன பண்ணாரு, he cannot be failed to explain MER by 2 MER, which is equal to NH by 2 pi. But the Louis de Broglie, he has to explain, he has to give the logical answer for the MVR, which is equal to NH by 2 pi. Otherwise the angular momentum, which is equal to NH by 2 pi. So this is the also called as the quantum condition for Bohr's atom. This is also called as the quantum conditions for Bohr's atom. So that's why you are saying the de Broglie and Bohr's concepts are argument to each other. Now let's say if the electron, it possesses a definite angular momentum, it can exist in phase. Otherwise you can say the circumference of the electron, it should be on integral multiples of wavelength of the electron wave. That is we know that 2 pi r, which is equal to n lambda. If it is 2 pi r equal to n lambda, the electron wave can exist in phase. Otherwise the electrons are revolve around the nucleus in a stationary circular path. Suppose the circumference 2 pi r is less than that of the integral multiples of wavelength. 2 pi r less than that of n lambda, it cannot be exist in space. Otherwise the wave not in space. Otherwise the wave is out of spaces. So electron or orbital revolve ஆகணும்னாக்கா for the condition 2 pi r equal to n lambda. That's why we are saying MER, which is equal to nh by 2 pi. Otherwise if it is not equal to 2 pi r, the electron wave is out of space. If the electron does definite the quantized angular momentum, electrons are revolve around the nucleus in a stationary circular path. That's why you are saying MER, which is equal to nh by 2 pi. So now you are showing what about the n value. If it is n value equal to 3, it just gives 3 amplitude. If n equal to 4, this gives the 4 amplitude. If n equal to 5, it gives 5 amplitude. If n equal to 6, this gives the 6 amplitude. Suppose it is not equal to 0, the electrons are easily collide with nucleus. So the structure of the atom will be collapsed. The atoms are unstable. So that's all about the quantization of angular momentum based on the de Broglie relation.
Applications of de Broglie's wave relation. This concept explains Bohr's postulates. That is, electron behaves like a standing wave around the nucleus. Due to this, energy of electron is constant while moving around the nucleus. Electron moves in quantized orbits because wave is continually in phase. Derivation. The circumference of the orbit should be an integral multiple of wavelength. 2 pi r is equal to n lambda, equation 1, where r, radius of orbit, n, whole number, 1, 2, 3, 4, to infinity, lambda, wavelength. But de Broglie's equation, lambda is equal to h by mu, equation 2. Substitute equation 2 in equation 1. 2 pi r is equal to n into h by mu. Mu r is equal to nh by 2 pi, equation 3. Equation 3 indicates quantization of orbit. Note: if 2 pi r n lambda or 2 pi r n lambda wave is not continually in phase, such an orbit is not possible. This concept gave birth to wave mechanical theory of matter. Limitation. This concept is only applicable to smaller macroparticles, particles like electron, proton. Reason. Mass of macroparticles is very small, so wavelength is very large. Experimental proof of this concept. In 1927, Division and Germer experimentally confirmed the wave nature of electron. They observed by diffraction of electron beams by crystal lattice